Acceleration, rate of velocity change. Acceleration is one of the most fundamental concepts in physics. It describes how quickly an object's velocity changes over time. Understanding acceleration is essential for analyzing motion in everything from cars on the highway to rockets launching into space. Before we dive into acceleration, let's clarify the difference between velocity and acceleration. Velocity tells us how fast something is moving and in what direction. It's a measure of motion at a particular moment. Acceleration, on the other hand, tells us how quickly that velocity is changing over time. Think of velocity as where you are now, and acceleration as how rapidly you're getting there or slowing down. The formula for acceleration is A equals delta v divided by delta t. Let's break this down. The letter A represents acceleration. Delta v, which uses the Greek letter delta, represents the change in velocity. Delta t represents the change in time, so acceleration is simply the change in velocity divided by the change in time. Acceleration is measured in meters per second squared. This may sound complicated, but let's break it down. Meters per second squared means that velocity changes by a certain number of meters per second, every second. For example, if a car has an acceleration of 5 meters per second squared, its velocity increases by 5 meters per second every single second. Positive acceleration occurs when an object is speeding up. When velocity increases over time, the acceleration value is positive. A classic example is a car accelerating from 0 to 60 miles per hour. During this time, the car's velocity is continuously increasing, resulting in positive acceleration. Negative acceleration, also called deceleration, occurs when an object is slowing down. When velocity decreases over time, the acceleration value is negative. Think of a car braking from 60 miles per hour to a complete stop. The velocity is decreasing, so the acceleration is negative. Here's an important point. Acceleration is a vector quantity, which means direction matters. Acceleration has both magnitude, which is how much, and direction, which is which way. This means that even if you're moving at a constant speed, changing your direction counts as acceleration. A car turning around a corner at constant speed is actually accelerating because its direction is changing. Let's work through a calculation example. A car accelerates from 10 meters per second to 30 meters per second in 4 seconds. To find the acceleration, we use the formula A equals delta v divided by delta t. Delta v is 30 minus 10, which equals 20 meters per second. Delta t is 4 seconds, so A equals 20 divided by 4, which gives us 5 meters per second squared. Here's another example with negative acceleration. A cyclist slows from 15 meters per second to 5 meters per second in 2 seconds. Using our formula, A equals delta v divided by delta t. Delta v is 5 minus 15, which equals negative 10 meters per second. Delta t is 2 seconds, so A equals negative 10 divided by 2, giving us negative 5 meters per second squared. The negative sign tells us the cyclist is slowing down. Acceleration appears everywhere in the real world. Vehicle acceleration and braking systems are designed with precise acceleration values in mind. Aircraft takeoff and landing require careful control of acceleration. Roller coasters use acceleration to create thrilling experiences. And perhaps most importantly, gravity pulls all objects downward with an acceleration of 9.8 meters per second squared. This is why everything falls at the same rate, regardless of mass. Understanding acceleration helps us analyze and predict motion in countless situations.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.